Hi, let's demonstrate the electronic configuration depends on the quantum numbers. So here we have the four quantum numbers Qn, which describe the properties of an element. The first one is the principal quantum number, which is being given the letter n, small letter, and this n could be the main shell number 1, 2, 3, 4, and so on. Then the second quantum number is the orbital quantum number. So the orbital quantum number is L, small letter. And this L could be 0. If it is 0, okay, could be 0, 1, 2, 3, and so on. So if it is 0, so the name of the orbital will be S. If it is 1, it's P, the orbital P. If it is 2, it's a D. And 3 will be F. The third one is the magnetic orbital or quantum number, the magnetic orbital quantum number. The magnetic will be M and the lowercase l. So ML is what? Could be. That belongs to the orbital. So if it is 0, plus 1, minus 1, plus 2, minus 2, plus 3, minus 3. The spin of electron quantum number, it's ms. The ms, if the electron, plus half means the electron is on clockwise spinning or standing. If the electron lower, so that will go half minus. Now, these are the main four quantum numbers which describe the properties of the element. So the first principal quantum number is n, takes number 1, 2, 3, 4. The orbital L, which is 0, 1, 2, 3. If the L is 0, is S, and 1 is P, 2 is D, 3 is F. The magnetic orbital quantum number is ML, which could be 0, plus 1, minus 1, plus 2, minus 2, plus 3, minus 3. And the spin one will be if the electron standing or clockwise rotation spinning, it will take the value plus half. If it is not, or the lower opposite will be minus half. So here, after we need to know something important is the ground state electronic configuration. The ground states determined by 3 rules or principles. The Aufbau principle, that the orbitals should be filled from the lowest energy level to the highest. The Hund rule will be we distribute the electrons singly, then doubly. And the Pauli exclusion says no two electrons have the same quantum numbers. Now, second thing we need to know is we need to go to how to distribute the electrons. So if you want to distribute the electrons, we need to memorize how to put the orbitals, suborbitals in order. So you go with first orbital is s, this is 1s, and then the 2s followed by 2p, and there is a 3s, 3p, 3d, and then 4s, 4p, 4d, 4f, and we come to 5s, 5p, 5d, and so on, 5f. There is 6s, 6p, 6d, and so on, 7s, 7p, 7d, and so on. So now, once we need to fill these orbitals, as you know, or we need to explain this, that the maximum of electrons in the s, how many? 2. And in every s, 2 electrons. And every p can take maximum of 6 electrons. And every d orbital